Hello everyone, welcome back to Unit 4 of our ICT course. In this course, in this unit, we are going to discuss about digital communication. Digital communication is what we are going to look at. So basically, when we talk about digital communication, we are talking about transmitting of information in the form of digital signals. All right, so we are using digital signals to transfer information. So unlike analog communication, all right, analog communication basically uses continuous signals. Digital communication, of course, however, involves discrete signals that represent information in a binary format. All right, so binary format, we're talking about zeros and ones. That's what the computer can understand. So this form of communication is, it's quite very common in the modern technologies such as computers, smartphones, okay, the internet, and digital broadcasting. Now, I want you to look at the difference that exists in the vehicles, all right? So if you've been in the car before, you may understand that on the dashboard of the car, there is what we call the speedometer. Now, on that speedometer, there are other speedometers that are, analog, and others are digital. Okay, so digital, they just show numbers here and there. Okay, and mostly these digitals are common in latest vehicles. The old vehicles, they've got analog system, all right? It's just numbers that are constant, that are stuck. So you may compare, you may Google about it and check how it is. But normally, with this modern technology, digital communication is very, very important in our study of the ICT course. Now, what are some of the basics of digital communication? Of course, there's the difference between digital signals versus analog signals. So what's the main difference? What's the main difference between a digital signals and analog signals? So digital signals are discrete and can only be, can only take a specific value. For example, 0 or 1. So those are what we call digital signals, all right? They can only take 0 and 1. Whereas the analog signals are continuous and can take on a range of values, all right? So the major difference that is there is that you see, digital signals are discrete. It means that they are measured in binary, zeros and ones, okay? It uses only zeros and ones. Then the others, which is the analog signals, they are continuous and they can take a range of values, okay? Now, you understand later what we mean by continuous, okay? Let's go on to looking at binary representation. Under, basics of digital, communication, we are looking at binary representation. Remember, we talked about binary as 0 and 1s. How does it work? How does it work? Okay, so we are saying that binary representation is the information that is represented using binary digits. Okay, binary digits are also called bits. Yeah, I'm sure you've heard of this word before, bits. So information that is represented in binary digits, which is bits, where each bit represents a 0 or 1. Now, binary digits, or what we call bits, each each figure, information is represented in bits by each figure. For example, 0 or 1. So the information can either be a 0 or 1. For example, if I say you press K on your computer, all right? You press K on the keyboard of the computer. That K is going to get a digital, it's going to get a binary code. For example, if it's a 0, it will get a 0, and it will communicate to the to the motherboard, or to the brain of the computer, which is the CPU. Okay, so you will understand later as we go on how the computer uses the zeros and ones as a binary option to communicate or to transfer information. Now, each element of digital communication, of course, that's the first thing. Okay, so the first thing that we're going to look at is the basic of the digital communication. The second one is the element of digital communication. What are some of the elements of this digital communication? How do you end up receiving a message on your phone? Okay, so the computer, for example, the smartphone, this smartphone, as you may see, okay, this smartphone communicate in numbers, in bits, because this is an example of a digital, digital transfer of information. This one purely uses digits. Okay, it's not binary. Let's look at this. Okay, my watch is also what? My watch is also it's a smartwatch. Because it's a smartwatch, it uses it also uses the latest system, which is digital, which is the which is the digital signals, all right, that we talked about. Remember, there's analog and, of course, all right. So all these latest computers, the vehicles, the touch screen, the numbers that represent there, those are digitals, all right. Now, elements of the digital communication. One, we have what we call the source. What is the source? The source is the origin of the message or information, all right? The origin of the message or information is called a source, and of course, there's what we call encoder, all right? So the encoder converts the source information into a digital format. So first of all, the information will come from the source. Once it comes from the source, it will be encoded. Once the information has been encoded, it will be converted. This encoder will convert the source information into digital format. It will first of all convert the information to a digital format before it is actually presented. Okay. Once it is once it has been it has been converted into a digital format, the channel will then, through, because the channel is the medium through which the digital signal is transmitted. So then this channel will transmit that information. Okay, it will transmit that information, and once the information is transmitted, these three, they work hand in hand to achieve a goal. Then we have the other one, the other element, which is the decoder. So the decoder reverts the digital signals back to its original format, to format at the destination. Okay, so destination, basically we mean the recipient, okay, or end point of the communication. Where is the communication starting from? So if this information starts, where is the destination? If I press K on my on my computer, all right, on the keyboard of my computer, I press K, or I press L, or I begin to type, the information passes through all these channels. First of all, it will come from the source, which is the keyboard itself. Okay, then the encoder will send that information to convert it to convert it into what? To go into the CPU. It will tell the CPU, hey, my friend, someone has pressed the K. You need to send the K to the what? To the screen. So that K, through the cables and through the other mediums, it will go and reflect on the screen. Therefore, I'll be able to see it. And that is what we call the destination. The destination is the screen. Okay, so once it reflects on the screen, that's a definition. Okay, that's the destination. Through channels, and the decoder will be able to receive it. In communication skills, of course, you may have learned the decoder and the encoder. Okay, the decoder, of course, the encoder is the source. All right, the source. The decoder is the recipient. Okay, so the third aspect we are looking at of digital communication is the digital modulation technique. All right, how is this information, transferred? It uses what we call the amplitude shift keying, ASCII. All right, amplitude shift keying. So this is it modulates the amplitude of the carrier signal. So remember, this information is transferred in signals, all right, the waves. You'll be able to know more. Okay, so there's what we call the amplitude shift keying. So this one, it modulates the amplitude of the carrier signal. Then we've got what we call the frequency shift keying. Frequency shift keying. So it modulates the frequency of the carrier signal. For example, sound. All right, how is the sound transferred from one phone to the other? Okay, how is the pardon me, so sorry. All right, so how does the information move from one to the other? So maybe, for example, on the radio, how do you call someone on the radio? It reduces what we call frequency. Okay, so this frequency, it carries the signal. Okay, now we have also what we call phase shift keying. So this phase shift keying, it modulates the phases of the carrier signal. Okay, it modulates the phases of the carrier signals. Now, in each signal, a signal is a wave, right? You may have learned in mathematics that the signal has got waves. Now, on the wave, there's what we call, a phase. Okay, a phase. A phase is a complete cycle of the wave. So it moves one, two. Okay, so those are what we call frequency shift keying. Now there's also what we call the phase. So apart from that, we've got what we call the quadrature. So this quadrature, amplitude modulation, combines amplitude and phase modulation. Now this information is just being shared with you because you're an IT technician. You need to understand this, but in this module we are not going to go too much into details, but it's eminent that you understand about the digital modulation techniques. Okay, how data is transferred, how is it recognized that this is a voice, this is sound, how does it recognize it that this is a document, how does it recognize that this is a picture? Okay, so some of these things are very, very important. Digital transmission. How then is this digital transmission conducted? Okay, so now digital modulation is different from digital transmission. Now let's look at serial versus parallel transmission. So serial transmission sends data one bit at a time. Okay, remember we said that a computer, the digital system sends the information in bits, all right? Okay, in bits. So each bit represents either 1 or 0. Okay, I know this may sound so confusing. Okay, but just hold on, understand the way it is, take your time, breathe. Okay, breathe, take your time. As you go on, you do more studies, you'll be able to understand it so easily. Okay, so serial transmission sends data one bit at a time. Okay, and parallel transmission sends multiple bits simultaneously. So when we talk about serial, a serial sends one bit at a time, whereas as parallel transmission sends multiple bits simultaneously. Okay, then under this transmission, when you're uploading one file, it's different when you're uploading multiple files. Okay, why? Because each file has to be processed according to its time. Then we have what we call synchronous versus asynchronous transmission. Okay, so this is the synchronous. Basically, to synchronize, we are talking about trying to refresh in a way, in a layman's language. Okay, so synchronous transmission uses a clock signal to synchronize senders and receivers. So you check, how do you realize that? You find that it will still continue to remember that you need to update. It's like updating for a conversation to go on. For example, you are sending an email, you are sending a WhatsApp message, you find that it will send, tick, it goes, okay? The system automatically begins to synchronize again to receive more data, okay? When somebody sends, it synchronize, update, and show you that somebody has sent another information, okay? So this, one bit, it sends one, see this synchronizing, it uses a clock. It has got a timer, the way it moves quick, as it is moving, it is updating, okay? Then we have what we call asynchronous, all right, transmission, okay? This one relies on start and stop bits for synchronization. You start it, it will continuously and constantly be what? Be transmitting information, okay? So basically, there's another component of error detection and correction. So these techniques like parity checking, checksums, and the cyclic redundancy check are used to detect and correct what? Errors. So basically, if there are any errors, they are used. Now, some of this data is complex, okay? Like just like you may have heard from this, some of this data is very, very complex. I will request that you take it the way it is, okay? I would request that you take it the way it is for now, and as we go on, most of these components will be able to patch up together, they'll be able to make sense, all right? And of course, there's what we call data compression. Have you noticed that when you send, well, maybe you may have not noticed, when you are sending a message on WhatsApp, make sure you upload it as a document. When you upload, for example, a picture will lose quality. It will no longer look the same. The size will also reduce. The bits will also reduce when you send it to another person. So if you send it into multiple medias, you download it on Facebook, from Facebook you send it to WhatsApp, from WhatsApp you go to Instagram, you find that the picture will reduce quality to begin to look blurred, okay? So why? It's because each platform, each digital communication channel like WhatsApp, Facebook, email, all of them are compressing the data, okay? So when they compress the data, it changes shape, okay? Now, compression techniques to reduce the size of the data for efficient transmission and storage. Basically, the reason why they do that is because they try to reduce the size of the data and save some space and be quick and efficient. When you find that you actually find that when the document is bigger, or a certain document, something that you want to send is bigger, it will not send quickly. It will take a lot of time. Okay, that's why if you upload a large photo on WhatsApp from the computer, it will take time to load, okay? So basically, when we talk about multiplexing here, time division multiplexing and frequency division multiplexing, these are techniques that are that are used to transmit multiple signals over a shared communication channel, okay? Then we learned about network and protocols in our previous studies, okay? Basically, this is about internet, and we use these protocols for us to send, because it has to, there's that IP address that has to identify you, which we looked at in the previous lecture, and of course OSI model, which divides network communication into 7 layers, okay, from physical to application layer. Are we together? So basically, digital communication system, of course, is in categories. The first category, we are talking about digital audio and video broadcasting. So here, example include DAB, okay, digital audio broadcasting, DVB, okay, digital video broadcasting. Here we're talking about audio. Is this information audio? What you're transferring, is it audio? Is it video? Okay. So all these have got their own dynamics. So digital communication doesn't just end on documents. It encompasses everything now, and especially now that there's even video conferencing, things have become a bit modernized. There's also what we call digital telephone. Okay, so this one utilizes digital signals for voice communication. So here you call a friend. Hey, where are you, my friend? I want to meet you. All right, that's what we call digital telephony. All right, so it utilizes signals for voice communication. And now in the recent years, we've actually seen digital audio and video broadcasting, where there's video conferencing. You can be able to chat with your friends, with your colleagues via video calls. All right, so of course, one important thing, of course, is security in digital communication. So these are some of the principles we need: cryptography and encryption. Basically, we are talking about techniques to secure digital communication from unauthorized access. You may have heard that, in Zambia some people are complaining that, their conversation were leaked. So it means that through some of these digital, through some of these signals for voice communication, some, network providers have been able to tap into people's phones and get the data, without permission, and release it to the public. Nevertheless, with this much, there's a concern of security and encryption. So for WhatsApp, you normally see the message to say end-to-end encryption. You actually should see, especially when you are doing a first-time communication with this individual, you will see WhatsApp will share with you that this is a one-to-one encrypted conversation. It means that the conversation is only between you and that person. No one else, no third party can tap into that, broadcast without access, without permission, or without being granted authority from you, or else you may have just been hacked in a way that you released your privacy information. Now, of course, we've got what we call secure socket layer, SSL. SSL is a lot. You actually learn it mostly in web design. Secure socket layer and transport layer security, TSL. These are protocols for that secures communication over the internet. Okay, so SSL you learn it a lot, and TSL you learn it a lot. These are protocols for secure communication over the internet. Okay, so of course, in the what we are looking at, of course, we are looking at 5G. 5G now is coming into use, and this is one of the fastest ways of internet. I think we'll be able to talk about it. Nevertheless, when you talk about digital communication, we are talking about revolution. All right, it has actually changed the way people transfer information. 15 years ago, WhatsApp was different from the WhatsApp that we have now. Okay, 15 years ago, we never used to have phones that we have now. Very efficient, very productive, very useful, and very beautiful. All right, so they've improved the way in which we are communicated together, in which we're gathered together. So I want you to take your time to go through these notes. Everything that you don't understand, take time to read more about it. Remember, me as your lecturer, I'll only give you 25%. The 75%, you have to look for it by yourself. Okay, there'll be an assessment, but after this we're going to go on and looking at the last part of this of this unit 4, and we'll be able to pick it up from there with a quiz. You have a great day until we meet next time. Goodbye.